So good afternoon to everyone, and thank you to those who've joined us. We are so excited, and today's webinar is going to be out of this world. So let's just quickly have a look at what we always ask you, just to please remember to mute yourselves during the presentation and to keep your camera off for better streaming. It just makes it a bit easier for everyone else to focus on what's happening in the presentation on the screen. And then please put your questions in the chat as always. I hope you can find the chat. I think we should know where the chat is by now. And please don't forget, at the end, there will be a link to a quiz and you could win the most awesome prize. And so you really don't want to miss that. So just stick around to the end so we can get that information to you. So let's look up. Clinton, over to you.
All right, good afternoon, everyone, and welcome to our webinar on the day after the winter solstice. And it is my pleasure to introduce to you a colleague and friend who I've worked with. Dr. Lelliott was previously an associate professor at Wits with me when we were both working at the Wits School of Education. And now he works in a private capacity for various consulting companies. So thank you so much for joining us today, Tony, and we really appreciate you sharing this with us. Over to you.
Okay, great. Thanks very much. I'm actually going to start to give people a minute because we're starting exactly on time. And I thought just while people want to get their heads in the right space, I thought I would just share this. That as something to look at. Sounds right. This is a view of the Earth taken from the ISS. It's quite nice to see the storm. So you see all those flashing flashings of lightning. And this is obviously during the night. And then right in the distance, you can see that little greenish object is really colored with the lantern. Different color. Anyone's interested in getting hold of something like that, you can just Google, and they're freely available. That was actually made from a composite from a number of images from the International Space Station, obviously speeded up as it flies over the Earth, or flew over the Earth. One was made a few years back. So what I'm going to be talking about today is looking up and encouraging. At Wits, I was teaching teachers. One of the things I tried to do was to encourage them all to look at the sky. And when Clinton asked me to present this today, I had a little brainwave and I thought, well, why don't we take a relatively recent film's name and change it slightly? If you've not seen this film, as geography teachers, I would thoroughly recommend that you do it. I don't know if it's still on Netflix. It was on Netflix. It's a comedy, and it is very well done because it's basically a metaphor for climate change. And the people who don't look up are the people who don't want to believe that a comet is coming to crash into the Earth and destroy all life. So it's well worth watching. Okay, so if anyone wants to take my email address, you're welcome to email me about any of the issues we cover today. And I think we'll get started. Are you hearing me okay? And is the visuals okay, Clinton?
All is good. All is good. Thank you.
Okay, thanks very much. Right, we'll go ahead then. And one of the things is that we know, and there's a part of a reason comes later in the presentation, why people don't really look at the sky so much. But people don't. Obviously, it used to be a major part of our heritage. Certainly thousands of years ago it was, and even hundreds of years ago. So the fact that people don't really look at it anymore is unfortunate. But it's very important, I think, as geography teachers to get students looking up, looking at the sky, because there's an awful lot of geography that you can learn from the sky, and geography-related issues you can learn from the sky. So showing them some simple things is the best way of doing that. And I used to try and do that by taking them outside the classroom and actually making them look at the sky. We were quite lucky at the Wits School of Education because we could go onto the top of our building on the roof and look at the sky with a relatively clear horizon, because it was like 4 or 5 stories high. And we could look at the horizon and see various things. When classes got up to about 150, I was always slightly nervous. I was hoping that the roof was built to withstand 150 people standing on top of it, but we never had any accidents. So taking people outside, first thing one should do is get them to think of the sky not as a flat sheet of paper, but a dome that they are looking at. And if they look straight up, they are looking, at the zenith, as it were. And if they were at the South Pole and they looked straight up, they would see the South Celestial Pole. We, of course, don't see that, but we are looking at a dome still. This is a nice, simple image of looking at the dome. So from Southern Africa, looking up at the dome, you're sort of looking at it, looking there straight up. So in the next image, it looks a bit complicated, but one could take a bit of time to interpret it and get them to. First thing I used to get them to identify was north, south, east, and west, because people don't tend to do that unless you're a geographer or whatever. And it's very important for them to know exactly where the 4 cardinal points are, and then talk about sun rising in the east, though we'll say, of course, a little bit later on, it doesn't actually rise in the east because it doesn't rise. But the sun rising in the east and then passing over and then setting in the west. And we're quite lucky because we are literally a day after our winter solstice. So we are our sun is actually rising north of east. This is something, if you had a chance to have the same group in the whole year, you could look at where the sun is over across the whole year. So it rises north of east and it sets north of west. So, and then looking, where would they see the South Celestial Pole? Well, they would see it in that direction. And I'll show you an image of that in a few moments. Okay, so the sky as a dome, that's one thing to get them to understand and think about these things. I must admit, I once had a question when I said, okay, so what's to the north of us? And people had a think. And then one student said to me, in front of everybody else, just said, well, look, I understand from where we are at Wits School of Education that Santon is in the north, but then what's north, what's north of Santon? They couldn't quite get the concept of north, south, east, and west as cardinal points. Okay, so moving on, one of the easy things to look at, get them to look at, is the sun rising and setting. But of course, it doesn't actually rise and set. And it's for them to understand it's not moving across the sky. Be warned, I'm going to ask you a question in a moment. So just get ready. It's a multiple choice question. So you could put the answer in the chat, please, in the next slide. So the sun moving across the sky, it's not moving. It's actually the whole sky moving. But in reality, of course, it's the Earth spinning on its axis. The sky isn't actually moving from our in some ways it is, but from our point of view, it's actually all the Earth spinning on its axis. And you've got to try and get them to imagine the whole sky moving above them. Although it's the Earth spinning, get them to imagine the whole sky moving and not just the sun itself moving across the sky separately from the sky behind it. It's some of these things are really difficult concepts, and we should encourage them to actually grapple with them. I'm going to give you a video in a minute to grapple with. Now we can demonstrate with a thing called stellarium, and I will actually go out of this for a moment, and I have a nasty feeling I didn't set stellarium up before we started, but that doesn't matter too much because now I can't find it. Stellarium, where's my stellarium? It's strange. I thought I had downloaded it and was using it the other day. So let's do a little search. Unfortunately, the thing is in the way. It won't let me type on it, which is not nice. That's interesting as well. Okay. Wonder why that's not working properly. So let me go to this and go stellarium. Sorry, I should have opened this to start with. Hope it doesn't give me a problem opening. Okay, so I would strongly recommend you download Stellarium. It's openly licensed, and it's a very useful visualization of the sky. So what I'm going to try and do is get you to understand a bit about the whole sky moving. And probably the most interesting is to look east, because I'm going to speed time up and sort of do that and then go fast and fast and fast. So we're now 4 o'clock. The sky is beginning to get a bit darker, and I will slow it. I'll stop it occasionally. Go on again. It's now 5:30. And if you look at the time at the bottom of the screen, it's 5:45. And we should start seeing, I'm in Gaborone, by the way, not in Joburg. You can begin to see stars now, as the sun has set in the west. And if we speed everything up, you will see what I mean about the sky moving, and for them to understand what the sky moving means. And if we want to take away the atmosphere, it gets even darker. We can see there, we have an atmosphere button, have all sorts of funny, nice little things on Stellarium. But get them to understand recording had stopped.
Okay, it started again.
Okay, so there's a question for you. What's the answer? And just bear in mind that it's developed for the Northern Hemisphere, so it doesn't quite work here. I've redrawn this, but I don't have access to it while I'm in Botswana. Now, ask students this before you do anything with the sky, getting them to look and understand what's going on, and then ask them the same question at the end of your little course. What is the answer? Anyone put in the chat? Aha, some chats here. We've got C. Any other alternatives to C? Okay, the answer is, let's look at that. Thank you, Clinton. Dr. K. Bryan and Clinton with the correct answer. Yes, the answer is, of course, C, because what's happening is that these constellations have risen here. Just forget about the north and stuff south here, because it's the northern hemisphere. They've risen here and they've moved across, and then they set there. And the sun, if it's in Gemini, the whole sky is moving. So therefore, but you see, people who don't think the whole sky is moving, they think the sun's moving across the sky separately from the stars behind it, would make a mistake. Okay, so there's a very good thing called the astronomy diagnostic test. It's quite old, and it's quite good about it's really sort of to diagnose misconceptions. Okay, so how can we demonstrate, or can we demonstrate it's moving? And this is quite a complicated video, and when you watch it, I think you will get confused. It is centered on the south celestial pole. So that is pointing to the south celestial pole. And does anyone know what these are? Put them in the chat if you wanted to. Okay, so it's night and day with the Earth spinning. And of course, it's in a particular position because the telescope that took this is centered on the south celestial pole, which is somewhere around here. And you can see occasional cars on the ground. Okay, so that's basically it. But it's sort of trying to get the idea that actually it's the Earth moving, it's not the sky moving. So really, in reality. But it does get people nice confused. We'll just pause that. Okay, so the idea of rethinking scale, rethinking perspective, rethinking context, these things are confusing. There's no doubt about that. By the way, if there are any questions or things in the chat, you'll have to draw my attention to it, because I won't really be reading them because my screen is taken up by the presentation. Okay, so that's diurnal motion. What about annual motion? And this was an idea from a geography lecturer at WITS. The idea of getting students to take photos of the night sky using their smartphone. And the idea, and so again, it's a thing for you to do with your students. And the lovely thing is that, like 10 years ago, not so many students had smartphones, but now so many more do, because they're more easy, they're cheaper. And you could take a photo every week for 1 month, or you could actually take a photo, let's say, 8 times in the whole year. And this time it's showing annual motion, which is the change over the year. Now, her advice was to use the lowest shutter speed. You'd have to know a little bit about taking pictures with your smartphone. And then you need to edit to increase the brilliance, the highlights, the contrast, the black point, the sharpness, and definition. So you'd have to do those things. And then her daughter, I think, took those two. Admittedly, one is much lighter than the other. But the bit I've ringed, you see, is the fact that it has those stars have moved slightly. Not very much, but they have moved slightly over the course of 1 week. It would be much clearer from exactly the same position. So you'd probably have to set up a thing like a tripod to do it. But it'd be interesting to do. So if you did a month apart, there would be definitely be more movings. So that's another thing to do. And that would then, why is there a change? We'd need to explain to the students about the stars, the constellations and stars changing throughout the year. And they would have to understand that, unfortunately, this is centered on South America. But let's imagine that we are somewhere in the Pacific here, where we would be looking out there that way into into actually the Milky Way, but looking out there into the sky. And then when we get to this position, we would be looking out directly towards us. And then when we get to that position, we'd be looking out directly that way, to the right, as it were. And then when we get that side, we'd be looking out away from us. So you're seeing different constellations over the course of the year. So get the students to understand there's the diurnal motion, and as well as that, there's annual motion. Okay, so something more down to earth / sky. We can look at let's go back to Stellarium. I want to show you, since we're already at Saturn, we'll look at what happens early tomorrow morning. You can see Saturn and Jupiter rising. We will look a little bit later on at two of the best constellations, really, Scorpio and Southern Cross, but for us at this time of year. And then in the evening, look at Mars and Venus and the Moon actually setting. So if we go back to Stellarium, and we go and speed time up again. So we've got Saturn rising. That's tonight. It rose around what, 11 o'clock? If you can see those times, I'm not sure you can see them very clearly, but that's the time. That we're now at 23:35. So Saturn will have risen. I'll speed time up so it's reasonably fast. Slow it down a little bit. It's rather force slowing and speeding. I need to go a little bit faster than this because of time we have today. But you can see Saturn is slowly moving up. We're looking east, remember. Let's move it a bit faster and we'll slow it down again. And a bit later, we should be able to see Jupiter. There it is. Oopsie, stop. Okay, so there's Jupiter rising as well after. And so if we, with Stellarium, you can actually make the screen smaller. I mean, further away, try and do that. Can't do that now for some reason. Some strange reason it's not. Okay, it's wanting to do that instead. Doesn't matter. But there's Jupiter. So we can click there. And if we click on it, it tells us all about Jupiter. And although it's not visible with the naked eye, Uranus is also visible there. And you'll get lots of amusement from your children when you talk about Uranus as a planet. So let's get moving up again. Okay, so let's just stop that and go back to now, which is before. I've turned off this thing jumping up is annoying. I've turned off atmosphere, put the atmosphere back on. That is our normal time now. Now let's go round to, I want to get rid of that Jupiter stuff. Okay, so if we go to the west, trying to get there we are, looking west. There's the sun. That's looking north, sorry. And northwest. Let's do northwest because things are reasonably clear in northwest. So there's the sun now. Let's I'm trying to get this. It doesn't matter. So now we want to speed time up again. And now we'll have the sun setting. Slow it down a little bit. Sun setting, followed by the moon setting. Yes, we need to speed up. Moon setting, and there's Venus close to the moon tonight, and also another planet you can see there, Mars, also showing. Let's just click on that. We don't have all. There's loads of stuff. I don't know quite how to get rid of all the blurb on the left-hand side, but never mind. And once I click on it, it seems to go away again. Right. Okay. So so those will actually set at. And you should encourage the students, by the way, there's a satellite going across the sky. There's another satellite going across the sky, which is nice. So it actually does track satellites as well, this program. So then let's go a bit faster. And with binoculars, they should be able to see Mars reasonably easily. They're setting at what time? 8, just after 8. They'll both be hardly visible, if visible at all, at that time, because yeah. So that's that's something in the sky. Now let's look at what's interesting in the sky tonight. And I wanted to, firstly, let's look at the Southern Cross. I want to turn the atmosphere. If we turn the atmosphere off, you'll see many more. You'll see the Southern Cross clearly in the Milky Way, and there it is. And with a couple of other bright stars nearby. So if you turn the atmosphere off, you can see things a lot more easily. But under normal circumstances, it would be something like that. And then let's go to, I'm lost in the sky where I am at the moment. Let's go to the east and try and see. I'm looking for, there we are, I'm looking for the Scorpio. It's actually much easier to see than it is showing here. But the Scorpion is here, there's the front of it, and it curls round to the tail there. And how do I know that? Well, I can, this is another nice thing you can put on this program. I'm trying to remember what it is. This one? No. I haven't used this for a while, so I think maybe it's that one. There we are. So you can actually give the names for all these things. We can see that the Scorpio is clearly there. So I would say those are the two best to look at in the sky at the moment. So, actually, Scorpio is better in South African cities because of all the light pollution, and you can actually see its stars pretty easily. Okay, moving on. How's my time going? 4 o'clock nearly. We're about probably a little around halfway through. I'm going to actually take you quickly through the moon phases presentation, because PowerPoint presentation, because I've used somebody else's and then tried to contextualize it for the Southern Hemisphere, so that so that one could, and you could take this. I mean, you can email me for it, or I can send it to Clinton or somebody, and you can put it somewhere and people can use it. But you do it. Warning: you do have to do your homework to really understand what's going on with moon phases, because anything that involves 3 bodies, Sun, Earth, Moon, even involving 2 bodies, Earth and Sun, it's quite complex to explain. If any of you try to explain these things to students, you'll know that it's quite tricky. So I would prepare well in advance. And of course, you've got to have a Southern Hemisphere view. And sort of 10 years ago, many of the South African books often even included a Northern Hemisphere view, but the newer books are better. And you just have to be careful. You go on the web, and then you see lots and lots of explanations because they're taken from the Northern Hemisphere view. And out of interest, I wonder how many of you know how many people live in the Southern Hemisphere in terms of percentage of world population. And you might be shocked to find that it's about 12 or 13% of the whole human population live in the Southern Hemisphere. So clearly the web, because of China, North America, Europe, etc., the web tends to be very biased towards Northern Hemisphere. Again, I'm going to run through this presentation in a moment, and I'm going to skim through it very fast because I want to get to the bit towards the end. But I just want you to see the sort of thing you'd need to do to talk to your students, to explain what's going on. An activity is to get them to do photographs or drawings of the moon over the course of a month, and note when and where in the sky they have to look to see the phases. So that's something they can also do. Again, getting them to look up. And it's very nice in the winter, very good winter activity, because the sky is relatively clear and you can actually see, you saw from that stellarium view that at the moment we've got a waxing moon in the western sky in the evening. Okay, so let's go to that other presentation, which I have a horrible feeling I didn't have open to start with. But it's here, fairly quick to run. And it's adapted from Mr. Valley's Guide to the Moon, which was on the internet when I downloaded it some years back. And I start with concepts. I'm not teaching here, so I'm just demonstrating. So I'm not intending to teach the stuff to you, but I tend to start with the concepts about the moon orbiting the Earth, the moon not producing its own light, the moon having half illuminated, the half facing the sun, and the part of the illuminated half that we see determines the phase that we see. And this is a very important thing because it's a southern hemisphere orientation. There's a nice, easy way of remembering, students to remember things. We start with the crescent after the new moon, then we have the full moon, and then we have the waning crescent at the end of the cycle. And a way to remember it is COD. There's a D, there's the D. So COD, you can sort of like a little mnemonic to remember the way which our cycle goes. Okay, so new moon. I talk about what a new moon essentially is, and then you don't basically see anything from the Earth. Then shortly after new moon, we have the crescent, and I'll just cycle through. We have the half moon, if you like. It's called the first quarter, not a quarter moon, but it's because it's quarter way through its cycle. And then we have the gibbous moon, gibbous phase, and then we eventually have the new moon when it's lined up nicely. So we've got those quite clearly there. And then we go for the gibbous, waning gibbous. We go the last quarter. We go and this one you only see early in the morning, the waning crescent, and then we're back to new moon, and the whole cycle is that length of time. Then there's just a few slides like this, and then there's something else I like to show. That's the actual size. You have to the scale of all these things in books and things is always way out, and that's the actual size. That's the length of time it takes for light to actually reach from the Earth to reach the moon, and vice versa. So I used to get students to model this with the moon as a hockey ball, the Earth as a basketball, and the distance between them. So it's quite nice to show that. So all of these things, very important to work with scale in these things. Okay, what about eclipses? Again, I'm trying to stress that these things are not to scale. And we've got the solar eclipse. I'm not going to go into the details of that because I want to get to the lunar eclipse. There's the solar eclipse. There's an animation of the solar eclipse, not a very good quality one, but there's an animation of a solar eclipse, and students can understand that. And then it's quite a nice, again, an animation where it shows the actual shadow of the moon during a solar eclipse moving across the Earth. Okay, and then the idea of the lunar eclipse with the sun, the Earth, and the moon, and very different sort of thing where they're lined up. In this case, the other way around. The moon is now full, and this is a image of a lunar eclipse. I don't think I've got a. Yeah, here's one that is an animation. What they will see in a lunar eclipse. And please note, if you want to note it down, 28th of October, we will have a total lunar eclipse. And at totality, actually, it doesn't go completely dark. It goes to a sort of orangish color rather than a total darkness. It's a reddish color. So 28th of October is something, if you're teaching this around that time, get them to observe the total lunar eclipse. Okay, and then the last couple of things I do is I don't know why I did that. I want to show the Earth, is to make sure people understand that our view of the Earth is upside down from the northern hemisphere view. So we are there, and then south is up from my point of view, and for the person standing there, north is up from their point of view. Again, a difficult thing a difficult concept for them to really understand, but you do need to spend a bit of time trying to encourage them to think about it. Okay, moving on, supermoons. Again, you hear quite a lot about supermoons these days. They never used to be in the press, but they're in the press a lot these days. August the 31st is probably the best supermoon of this year, but there's one quite soon. And because the moon is in an elliptical orbit around the Earth, it's closer at some periods, sometimes, than others throughout the year. So a supermoon's when it's a bit closer to the Earth, and it's a tiny bit bigger, very, very small percentage. And there's going to be there's going to be four in consecutive months this year, and the best one is actually August 31st. The press are going to mention it. To be honest, I'm not that excited about supermoons because I can't really see the 10% bigger size. I think people tend to, but they might ask you about it because it's there in the press and there it's on social media and all that sort of stuff. But supermoons, just at least know a little bit about them. Okay, so sort of moving towards the end now. I'm going to cover briefly light pollution. And there are big problems. They're realizing more and more there are big problems with light pollution, particularly in the natural world. Insect navigation and even breeding cycles and things like that are messed up by light pollution. And literally millions of birds are killed because of lights every year. It does also harm melatonin in us. There are some indications there are health implications for that. There's a lot of wastage. People don't tend to remember that, but there's an awful lot of wastage in costs of, even if they're LED bulbs, they still cost. And when you multiply those up by millions, obviously there's a lot of wastage of energy. And of course, from an astronomer's point of view, there's the loss of view of the night sky, which is unfortunate, very unfortunate, and one of the reasons people don't look up. So there's a very good citizen science activity. And again, as teachers, I would encourage you to get your students involved in citizen science because there's a very good web app that you can use. You can use it on a computer, but you can actually also use it on a phone. And you can look up and look at some stars. It's usually from our southern hemisphere, it's usually Orion's belt, which is not really visible much this time of year, and the Southern Cross. And you can give them, you do an estimate of how many other stars you can see around it, and it gives an indication of how bright the sky is, i.e. how much light pollution there is. So it's well worth going to this. You can just Google it again, globe at night, and it's well worth having a look and encouraging maybe some of your students who are a sort of thing you could do as a club extra activity because you could get them back at night and could talk to them about that sort of thing, or just get them to do it from their houses. But it's good because there's still not enough data points in Southern Africa. So it's good, especially if you are teaching in a rural area, you'll have a lot less light pollution than we do in our urban areas. And I'm sitting outside Gaborone, about 15 kilometers, and I can tell you, the light pollution here has increased a massive amount over the last 20 years. We had this house built in 1989, so I've seen things change an awful lot. One other amazing thing I saw in 1987 was a supernova in one of the clouds of Magellan. Earlier, I mentioned to you when you saw that Earth spinning around I said that what are those two things? I forgot to tell you what they were. They're the clouds of Magellan, which are distant galaxies. And in 1987, there's a very famous supernova which went off in 1987 in one of the clouds of Magellan. And you can still see with the telescope the remnants of that supernova. I didn't know what it was at the time. There was no internet. One thing, I was just very surprised to see a bright star in in the cloud in that galaxy. Okay, I'm going to finish off now because we're sort of 10 past 4. I'm happy to answer questions, and also if anyone wants to, people could add as well ideas that they've had. So a very important space mission at the moment is the James Webb Space Telescope, which is more or less taking over from Hubble, in that it works in the infrared range, and there are some very, very good telescope websites, and they have student activities on them. So again, sort of citizen science type stuff, you can get your students to look at those. You will always find in classes, usually like 5 or less students who are really quite excited about astronomy things. So you can get some of those people to maybe do a presentation to the rest. And then, I mean, that's a famous picture from the James Webb Space Telescope, but similar thing from Hubble. Many of you will know that they decided to point the Hubble years and years and years ago at a completely dark patch of the sky, where they couldn't see any stars at all. And they let Hubble look at that patch for a week, and they saw something very similar to this. It's called the deep, can't remember what it's called, deep space field or something like that. So those are all galaxies. Every single spot of light there is a galaxy, not a star. So just showing the massive numbers of galaxies that are out there. The James Webb Space Telescope did a repeat of this. Hubble took about a week to get all the data in. And I think the James Webb Space Telescope took a few hours to get an equivalent photograph. So it's that much more powerful. Okay, some other recent space missions. Again, I would strongly recommend, if you to get kids excited about this sort of thing. Something that was going on when I was teaching at WIT was the New Horizons mission, which actually did a flyby of Pluto, the top image there. We never had any idea really what Pluto looked like. It was just a little white fuzzy blob in the sky. But the New Horizons mission flew there, and then it passed it, and it actually then flew onto another dwarf planet, because as you probably know, Pluto is a dwarf planet, and there's another one out there called Ultima Thule, and others. And they are all in the Kuiper Belt, which is right at the edge of our solar system. So it's still got massive amount of data from the New Horizons mission, which is still going out there, but I think they're scaling down anything to do with it these days. Something to look at that's currently ongoing. So if you want to look in the next year or two, is the JUICE mission, which is the European Space Agency, and it's looking the icy moons of Jupiter. Jupiter, as you know, got lots and lots of moons. It's got some icy ones, and this spacecraft is going to take photographs of the moons, some of the moons of Jupiter, ones particularly that are covered with ice. And then 24th September, excitement that the OSIRIS-REx, this spacecraft landed on an asteroid, picked up a sample of the surface, and then flew back to Earth, and it is landing on the 24th September. And that little thing is an image of the asteroid in, I think it's, I don't know what, infrared or something, I can't remember, but what the asteroid looks like, a little asteroid way out in the asteroid belt. So those are the sorts of things that you can do, and but that's really all I'm going to cover now. It's 4:15, so it's about 45 minutes, but getting students to look up as geography teachers, I think is very important, because it is part of geography. Obviously it's earth science, but also it's planetary science, and then also it's aspects of astronomy. When you're looking up into the sky, you're seeing various things, the simpler parts of astronomy, not going into the details of astrophysics, etc., etc. Good. Okay, so that's all I'm going to cover now, and I think I will stop sharing.
Thank you. So I'd like to find out if there's anyone with any questions, and I'll start with one. Which is the best cell phone app that you use for looking at the sky?
They change over time. Depends if you've got an iPhone or an Android. I have actually, one of my favorites, just to see which planets are visible. I've got a little collection of astronomy apps on my phone, so I'll just describe them. There's one simply called Planets, and Planets is it basically shows which planets are visible when, and you can put in any date, but obviously your default date is tonight. So it will show that Jupiter and Saturn will be rising later, and Mars and Venus will be setting. So planets is very nice. Then there's quite a lot that you can hold up to the sky and look through. Planets can do that as well. I would download 2 or 3 different ones if I were you, because some are better than others. I use a thing called Private Universe. Maybe I'll put them in the chat. Private Universe, I think it's called Private Universe. It's called Pooniverse, P-U, Pooniverse. Just 1 second. So Pooniverse, and then Star Map 3D is another one. If you want to look for satellites, a very good one is called Heavens Above. It's actually a website, Heavens Above. And I also have a thing downloaded called Sunrise Times. I find it very useful to see sunrise times because I'm in different parts of the world when you're traveling. There's a couple of I've got that I don't use so much. One is called Sky Orb. There's a very nice one called Astrolabe, which mimics a Middle Ages astrolabe. So I would strongly recommend Astrolabe just for fun, because it's like an astrolabe. And there's a last one I don't use at the moment is Sky Portal. So I'll try and stick them in the chat. I'll try and stick them in the chat.
Thank you.
While we're going on to the question.
I'm actually going to use it for my own children because they're quite fascinated. They're forever asking questions and then I can't answer.
Sure. Okay, so I'm going to say, so my favorite is planets and stuff, but.
Okay, while you're busy putting that in, I just want to tell the people who are online with us that there is a quiz which they are very welcome to do with us. And I'll put the link in the chat as soon as everything else is done. And hint, you might need to see something on the screen to get that right. But please do, because it's a really great prize that you can get, which Pam will be sending to you in due time. So there has to be some really great reason for listening to us this afternoon. And there's the form that you can just fill in. It will go to Pam, and then she will be able to announce a winner sometime next week. Okay, so if you look in the chat, you will find the Google form. If you need me to email it to you, please just let me know and I will do that as well. Dr. Lelliott, I see someone also asked about a climate change movie that you would suggest. So besides the Don't Look Up, do you have another movie which you think is good for the students to watch?
Not at the moment. I haven't. But I mean, I'd say this one's for adults, not particularly for adults, but it's but I don't know. I'm sorry, I haven't got a particularly good one for kids to watch. I mean, I think they would enjoy Don't Look Up, but it's on Netflix and stuff. But
yeah, I think
you
so
can have
too.
a look at it and see.
Okay. Thank you so much for putting those apps in there as well.
Sorry?
Sorry, did someone ask something? Are there any other questions? Well, thank you so much for joining us today, Dr. Lelliott. We found that fascinating. I'm looking up in future. And I'm pretty sure that we can definitely use a lot of this for our high-tech students in our classes, and getting them just to have a look and use their phones as well to get this.
Yeah. There's so much more. Clinton mentioned Star Walk. It's very good. I just don't seem to use it these days. But anyway.
Okay. So thank you so much to everyone for joining, and we'll put the recording onto the YouTube, and then obviously we'll also let everyone know about who won the quiz and concentrated. Thank you so much. Right, have a good afternoon, everyone.
Well, thanks very much.
Thanks.
Thanks, Tony.
You.
Keep well, everyone. Thanks. Cheers.
Okay, bye.
Thanks.
Okay.
Thanks very much. It was great. Thank you.
Bye.
Thanks.
Bye.